For lesson 8.2, we're going to talk a lot about factors today. So our first part is to look at our learning goal. So our learning goal, there are a couple pieces to it. Number one, I want you to be able to find factors. The second part of our learning goal is I want you to be able to use something called factor trees, which I think you learned about in 4th grade. Use factor trees to find the prime factors of a number, and we'll talk about what those mean in just a second. And then the last part, you'll be able to use factor trees to solve for a missing exponent. So when you've got a number that has an exponent and the exponent is missing, that's what we need to use factor trees to help us solve. So by the end of today, this is what I would like you to be able to do. Vocabulary that you need to know. A prime number is a number that is only divisible by itself and 1. So some examples, a number that's only divisible by itself and 1. 1 is a prime number, 2, 3, not 4, because 4 is divisible by 1 itself and also 2, and then you can keep going. A factor. Factors are any numbers that multiply together to make a larger number. Next up, factor tree, and we'll go into these a little more in the video. A factor tree is a diagram or a picture type thing that is used to find prime factors of a given number. And common factors are factors that a set of numbers have in common. Okay, so let's review. If you remember way back at the beginning of the year, we were working on finding factors. And I told you we were going to find a factor rainbow, if you remember. So if we're looking at 15 and we do the factor rainbow, we could do it a couple ways. We know 1 and 15. We can connect them. This is where the rainbow comes in. Now we just work our way up. 2. Does 2 times anything get us to 15? No. How about 3? Well, we know 3 times 5 gets us to 15. And now there's 4 times 4 does not get us to 15. So those are all the factors of 15. Now you could also write it 1, 3, 5, 15, or you could write them together, 1, 15, 3, and 5. Whichever way works best for you, it doesn't matter to me as long as you got them all. Next one, find the factors of 24. So 1 and 24. Let's see, 2 times 12 gets me to 24. 3 times 8. 4 times 6. And now the only one in between those is 5, and 5 times nothing gets me to 24. So again, you could write these out this way if you'd prefer. Write them out in pairs. Either way, it doesn't matter. Now the next part says to circle the common factors. So remember, each of these, I'm putting a little X there because it means you're multiplying them to get to your number. Okay? So now we need to look for the common factors. So if we look at our list here, we've got 1, 3, 5, and 15. So 1 and 1, that one they have in common. 3 they have in common. 5 they do not, and 15 they do not. So the common factors here are 1 and 3. Now if I'm looking for the least common factor, it's going to be the smallest factor they have in common that's not 1. So the least common factor would be 3 in this case. Alright, I want you to take that and try and solve this next one. Find the factors of 20, find the factors of 32, circle the common factors, and then I would like you to list them here after you've circled them up here. And then come back to me and we're going to work on the second page that you have attached to that. Alright, now take out the next page that you have attached, and I want you to turn to this part that looks like this. I'm going to do an example with you, and then I'm going to have you do a couple on your own. So this is a factor tree when you look at the insides of it. So we're going to do number 1 together. So we've got our number 40. And the first thing we need to do is, what can we multiply to get to 40? Now, the way that I do it is I start with, if it's an even number, 2 is always going to be a factor. So I start with that. So I know 2, and since this is a circle, what the circle means is that that number is prime when you see that. So 2 is a prime number. So 2 times what? 2 times 20. Okay, so now I'm looking here again. I know again 20 breaks off into 2. 2 is another prime number. 2 times what gives me 20? 10. Okay, so now I've got 10. And I've got 2 prime numbers coming off it. So something times something gives you 10, and they're both prime. That would be 2 and 5. So this is a completed factor tree. We're just breaking it down. Now the next step, where it says prime factors, we look at all of these that are at the tail end of the tree. It's almost like these are branches, and these are the leaves sticking off of it. So once you get all the way down to the leaves, that's the numbers that you write down here. So I'm going to look at them. I've got 2 times 2, and I'm gonna, since I have a 2 over here, I'm gonna write that in there too, and then 5. So we've got 2 times 2 times 2 times 5 equals 40. Now there's another way for you to write this. If you remember back from yesterday's video, from 8.1, 2 times 2 times 2 is the same thing as saying 2 to the 3rd power, or 2 cubed. And then, we can't forget about the times 5, equals 40. That's just another way to write it. If you would like a little bonus, try that if you can on these ones as well, if it actually lends itself to doing that. Some of them might not. So now I want you to pause it, and I want you to try and do number 2 and 3, the factor trees for 92 and the factor trees for 90. Okay, if we look at the next one down here, you notice you have 3 problems, and I left you a whole lot of room. Now we're going to go, if we look back at our learning goals, we find factors. We've already found them. We've been able to use factor trees to find prime factors. That's what you just did. So now we're going to move on to using factor trees to solve for a missing number, a missing exponent. So I've got 2 to the x power equals 32. So we're going to make a factor tree out of our big number 32. So this is a chance for you to actually start making them without having all of the branches and leaves filled in for you. So 32, I'm going to start with 2 again, because that one seems to be easy. Alright, so 2 times what gets me to 32? 16. Well, I know 2 is prime, so I'm going to go ahead and circle it. I'm just going to leave 16 alone. If you want to put a square around it, you can, but you don't have to. Alright, so 16. Try and break that into more. So I know 2 times 8 gives me 16, and 2 is a prime number. Now 8's not a prime number. I know 2 times 4 gives me 8. Is 4 a prime number? Not yet, because I know I can still multiply something to get there. So 4 is 2 times 2. So now I've got, if I was to rewrite this out, I have 2 times 2 times 2 times 2 times 2. And we learned in the last video how to rewrite that in exponential notation. 2 is my base number, and how many times did I multiply it by itself? 1, 2, 3, 4, 5. 2 to the 5th power. So now if I look back over here, take this number, and I look over here, 2 to the x power equals 32. Well, we just found out x equals 5. So now I want you to take your next numbers, and you can just box them off if you want. I know I wrote mine kind of big. You guys won't all write them as big as I did. And I want you to make factor trees out of them and see if you can break them down. Now if you forget, go back and look at them. Now 11 to the x power equals 121. It's not quite as simple because there's not a 2, but you will be able to find it because look, 11, I'm sorry. 11 times what gets you to 121? You can figure that out. Okay, and from there, 27 you can also do. So go ahead and try and answer those two questions, find for the missing exponent, and then come back to me and we'll finish up. Alright, for this next one, prime factorize the following using the factor tree method and rewrite as exponents. This is just another way for you to get a little bit more practice. So if you take a look at 39, all I want you to do is come up with a factor tree for it. Well, I know 2 doesn't go into it, but 3 does, and 3 is also a prime number. So 3 times what gets me to 39? If you don't know that, use your division you've practiced. 3 goes into 3 once, 3 goes into 9 3 times. So 13. And is there anything that multiplies by itself to get to, or anything that you can multiply to get to 13? Nope. So 13 is also prime. So this is what I'm looking for you to do here. Then, if possible, rewrite it as exponents. This one, you just would rewrite it 3 times 13. This one, however, you will find that you'll need to rewrite it in exponential notation. Now, the last set of problems, this time you're taking a known exponent and you're trying to break it down and find the base. So for this one, you're taking your big number, 64, and you're making a factor tree out of it. So what could we get? Let's see. Alright, so for this one, it's a little bit trickier because I'm thinking, what do I know? Well, I know 8 and 8 is 64, but I need to get something cubed. So if I break this down even more, I've got 4 and 2, 4 and 2. Well, still, I don't have anything times itself 3 times, but I have 4, and I have 4. I shouldn't have circled those, they're not prime. If I look at this 2 and 2, that together makes another 4, because these are all multiplying. So when you're looking at these, you have to pay attention to what power it is. So x is actually going to be equal to 4, because 4 cubed equals 64. Okay, so now use that to try and figure out this one. And I know this looks tricky, it's really not. Think about what you could break this down. Big numbers you could break this down into to multiply, and you'll be able to figure it out. So give it a try. We'll go over questions in class.